It's still there this morning. You didn't check. You didn't have to. You woke up, light was coming through the window, and somewhere in the back of your mind you filed it under constants. The things that don't need a second thought because they've never once let you down. The sun rose today, it'll rise tomorrow, and for roughly 5 billion more years, that's going to stay true. But here's what nobody mentions at breakfast. That star, your star, is already dying. Right now, this moment, while you're watching this, the sun is consuming itself from the inside out, burning through 4 million tons of its own mass every single second. And it's been doing that since before the first fish crawled out of the first ocean. The light hitting your skin right now, it was generated inside the sun's core 100,000 years ago. It spent that entire time fighting its way outward through layers of plasma so dense that a single photon moves slower than a garden snail. It finally got out, traveled 93 million miles in 8 minutes, and landed on you. That's not the part that should keep you up at night. The part that should keep you up at night is what happens when it stops. Because the sun's death isn't just some astronomical event. It's not a number in a textbook. It's the end of every ocean, every mountain range, every city that will ever exist on this planet. It's the final chapter of Earth's entire story, written in plasma and gravity, and a scale of violence so absolute the human mind genuinely can't process it without flinching. So let's not look away. The sun is 4.5 billion years old. It's halfway through its life. Think about that for a second. This thing, 865,000 miles across, massive enough to fit 1,300,000 Earths inside it, is middle-aged. And like anything middle-aged, it's slowly, almost imperceptibly changing. Right now, the sun burns hydrogen. That's the deal. Gravity crushes hydrogen atoms together in the core until they fuse into helium, and that fusion releases the energy that lights the entire solar system. It's been that deal since the beginning. It's a good deal. But here's the thing. Hydrogen runs out. The core is already accumulating helium ash, the byproduct of all that burning. And helium doesn't fuse at current temperatures. It just sits there, dead weight. As that helium core grows, the hydrogen burning migrates outward into a surrounding shell. Pressure changes, temperature changes. The star starts behaving differently. This is already happening. It's happening right now, 400,000 miles beneath the surface, and you'll never feel it. Your great-great-grandchildren won't feel it. Nobody alive for the next billion years is going to feel it in any meaningful way. But the star is changing, and here's where it gets wild. In about 5 billion years, the hydrogen in the sun's core runs out completely. Fusion in the core stops. Gravity, which has been held back by that fusion for 5 billion years, reasserts itself. The core collapses inward under its own weight. That collapse generates heat, enormous, catastrophic heat. And that heat ignites the hydrogen shell around the core in a fusion reaction so violent, it's almost impossible to wrap your head around. The sun's outer layers respond to that explosion from inside by doing the only thing they can do. They expand, not a little, not gradually in some way that gives anyone time to adapt. The sun becomes a red giant. Over the course of millions of years, it swells outward, past Mercury, consuming it completely, past Venus, vaporizing it. The sun's surface, which right now sits 93 million miles from Earth, starts creeping closer. At its maximum size, the sun will be 200 times its current diameter. 200 times. Lay 200 suns end to end. That's the radius of what your star becomes. Now, what happens to Earth at that point? That's actually still debated. The expanding sun might engulf us directly, or the solar wind, which gets dramatically more intense as the sun swells, might strip away Earth's atmosphere long before the surface burns. Either way, by the time the sun hits full red giant phase, the surface of Earth will reach temperatures above 1,000 degrees Celsius. The oceans evaporate, all of them, every single drop, every ocean trench, every Arctic ice sheet, every river delta, gone in a global steam event that strips the sky itself away. The rock melts, mountains collapse into lava flows that cover the entire surface. The crust itself liquefies. Earth doesn't explode or shatter, it just melts. Slowly, over millions of years, until what's left is a glowing, featureless ball of molten rock, still orbiting what used to be the sun. But here's the thing, that's still not the most terrifying part. Okay, imagine you're standing on Earth's surface during the early stages of the sun's red giant phase. The sun is enormous in the sky, not the compact, almost coin-sized disk you see today. Something vast, something wrong. A red, roiling wall of fire that stretches from horizon to horizon. Surface temperature, 400 degrees Celsius. Your lungs try to take a breath. The air, what's left of it, is a thin, scalding mix of steam and carbon dioxide. It doesn't burn your lungs because there's not enough of it left. There's almost nothing to breathe. Your cells start to asphyxiate within seconds, but you don't even get that far. The radiation hits you first. Without the magnetic field, which has weakened dramatically as Earth's interior cools, the solar wind scours the surface directly. The UV radiation alone is 10,000 times what you'd get on a sunny afternoon. Your skin doesn't tan, it doesn't burn, it starts to disintegrate at the cellular level in under a second. You look up, the sky isn't blue, it isn't even red, it's white. A flat, annihilating white. The color of something so hot, it's passed through every other color and come out the other side. You don't see it for long. But here's the thing, and this is real, this is actual science, this genuinely matters. None of this happens to anyone we know. Not to any human who's ever lived. Not to anyone alive today or in any foreseeable future. The sun's red giant phase kicks off in 5 billion years, and Earth is 4.5 billion years old right now. The Earth has lived half its life. Somewhere out there, right now, there are planets around younger stars where this whole drama is only just beginning. And there are planets around older stars where it already ended. We're in the middle of the story. That's not nothing. After the red giant phase, something beautiful happens. The sun's outer layers, all that expanded plasma, all that bloated stellar material, gets ejected into space. Not in an explosion, more like a long, slow exhale. Over tens of thousands of years, the sun sheds its outer layers in concentric rings of glowing gas. This is called a planetary nebula. The name is actually misleading. It's got nothing to do with planets. It's just what early astronomers thought they looked like through small telescopes. What they actually look like, what Hubble has shown us, is one of the most beautiful structures in the known universe. Rings within rings. Colors that don't exist in any earthly sunset. Electric blue, deep violet, magnesium white, ionized oxygen green. A sphere of dying stellar material expanding outward at tens of thousands of miles per hour, lit from within by what's left of the sun at the center. And at the center of all that beauty, a white dwarf. The sun's core, compressed by gravity into a sphere roughly the size of Earth. A sphere containing the entire remaining mass of the sun. A sphere where 1 teaspoon of material weighs 15 tons. The white dwarf doesn't burn. It doesn't fuse anything. It's not really a star anymore in any functional sense. It's just a hot, dense, slowly cooling ember. The dying remains of the fusion engine that powered this solar system for 10 billion years. Get this. It'll take longer than the current age of the universe just for it to cool down. Longer than everything that has ever existed has existed. It'll still be out there, cooling, dimming, fading, long after the Milky Way itself has changed beyond recognition. And here's the part nobody tells you about this. That white dwarf will still be orbited by Jupiter, by Saturn, by the outer planets that survived. A dead star surrounded by a graveyard of frozen worlds, drifting through a galaxy where nothing remembers what this system once was. Here's the revelation. The atoms in your body, the carbon in your DNA, the iron in your blood, the calcium in your bones, they weren't made on Earth. They were forged in stars. Stars that lived their full lives, expanded, burned out, and exploded, scattering their material across the galaxy. You're literally made of dead stars. And when the sun finally dies, when it sheds those outer layers into that planetary nebula, The material it releases will drift through space for millions of years. Some of it will get caught in the gravity of a collapsing cloud of gas. A new star will form, planets will condense from the leftover disk, and some of the material that used to be the sun, that used to warm the oceans of Earth, will end up in the soil of a world that doesn't even exist yet, in the body of something that hasn't been born yet. The sun isn't just going to die, it's going to become something else. It's going to become part of the next generation of stars, of planets, maybe of life. Everything burning in this solar system right now is fuel for something we can't even imagine. And here's the weight of that, the real weight, the kind that takes a moment to actually settle in. The sun has already outlived every star that came before it. Every atom in your body passed through at least one stellar death before it became part of you. You are the universe's way of looking back at itself. And the sun, this ordinary middle-aged yellow dwarf star you forgot to think about this morning, is the reason any of that was ever possible. For now, 5 billion years is an incomprehensible distance. But the sun is already burning. It's always been burning. And every day it rises, it does so with a little less than it had the day before. The light on your face right now, that's not a given. It's a loan. One day, something very far from here will look up at a night sky and see a faint white star where ours used to be, if it can see it at all. It won't know what we were. It won't know what we built or loved or feared or figured out. It won't know about the first fish or the first city or the first telescope pointed at the sky, but the atoms will be there, scattered in the dark between the stars, drifting towards something new. Will still be there. If that left you unsettled or strangely okay with everything, subscribe. There's more where that came from. The universe has a lot more endings to show us. The death of the sun, what actually happens when it dies. The sun rose this morning. You didn't think about it. You should. In roughly 5 billion years, the star that built the solar system will begin its death sequence. And the process is far more violent, far more beautiful, and far more personal than any textbook ever told you. In this video, we walk through every stage of the sun's death. The slow accumulation of helium ash happening right now inside the core. The red giant expansion that will vaporize Earth's oceans. The planetary nebula that will scatter the sun's remains across the galaxy.